Welcome to Chemistry with Ayush. In this channel, we will share some videos related to chapters for the exams like JEE Mains and JEE Advanced. JEE Advanced. Today we will start with a new chapter, chapter 1, that is Stoichiometry. So the first question comes, what is stoichiometry? Now, it is the process of determination of proportion by which elements or compounds react with each other. Next, we will study about basic particles of atoms. Okay. So we know that there are three subatomic particles of atoms, namely electron, proton, neutron. Okay. Here it is a table. This column, there are four columns. First is name and representation, second is charge, third is mass, and the fourth is discovery. Let's start with electron. So electron, now electron is represented as like this, E E0 minus 1, or we can write as beta. Okay. Now what is the charge of electron? Minus 1.602 into 10 to the power minus 19 coulomb. We can also write as minus 4.8 into 10 to the power minus 10 ESU. Mass. What is the mass of electron? 9.11 into 10 to the power minus 31 kg, or we can also write 9.11 into 10 to the power minus 28 gram. Who discovered electron? That is J.J. Thomson. Next is proton. Proton is represented like this, P11, or we can also write here I am writing H plus. Okay, why we are writing H plus? Because when one electron is removed from the hydrogen atom, it becomes a proton. So H plus is also the representation of proton. What is the charge of proton? Plus 1.602 into 10 to the power minus 19 coulomb. What is the mass? 1.67 into 10 to the power minus 27 kg, or 1.67 into 10 to the power minus 24 gram. Next is neutron. Charge is 0. Mass is 1.67 into 10 to the power minus 27 kg, or we can also write 1.67 into 10 to the power minus 24 gram. Who discovered neutron? James Chadwick. Now we are coming to some important definitions. First is isotopes. What is isotopes? Atoms of same element. Okay, so it should be atoms of same element having same atomic number but different mass number. Such as we have taken the example of hydrogen, H11, that is protium, H21, that is deuterium, H31, that is tritium. Sometimes we say heavy water, but the formula of water is H2O. So what is that? Deuterium. Okay, water consists of two elements, hydrogen and oxygen. That hydrogen is deuterium, so we called as it is heavy water. Okay, this line is very important. Mass becomes fractional due to presence of isotopes. For an example, Cl. Okay, for an example, Cl, that is chlorine. Chlorine has two isotopes, right? One is 3517 and another is 3717. But what is the average mass of chlorine? That is 35. That is 35.5. So you can understand from this example. So mass becomes fractional due to the presence of chlorine. Because of chlorine having two isotopes, so its mass number, that is average mass number, is 35.5. Next Next we are coming to isobars, that is atoms of different elements having same mass number but different atomic number. So what it is, now isobars are the atoms of different elements having same mass number. For an example, this you can see carbon 14,6 and nitrogen 14,7. So you can see that the mass numbers are same. Okay. Next we are coming to isotones. It is also called isotonic species. What is the definition of isotonic species? Atoms of different elements having same species of neutrons. Okay, atoms of elements having same species of neutrons. For an example, you can see hydrogen, that is tritium 3,1 and helium 4,2. So number of neutrons in tritium 3 minus 1, 3 is mass number and 1 is atomic number. So 3 minus 1 is equals to 2. And in case of helium, if we come to helium, He 4,2, so 4 minus 2, 2. So we can see that in these two elements the number of neutrons are same. Okay. Next we are coming to isodiaphers. What is the definition of isodiaphers? Now, atoms of different elements having same difference of neutron and proton. So isodiaphers are the atoms of different elements having same difference of neutron and proton. We will take an example. Okay, see fluorine F919. 19 is the mass number and 9 is the atomic number. And potassium K3919. Okay, number of protons. What is the number of protons in fluorine? 9 and potassium 19. Now neutron in fluorine, how neutron is calculated? Mass number means A minus Z. A minus Z gives you neutron. Okay, that is mass number minus atomic number equals to number of neutrons. So 19 minus 9 equals to 10, and in case of potassium 39 minus 19 equals to 20. Now we will look into proton minus neutron, that is the difference of neutron and proton. Same. So 10 minus 9 is equal to 1 and 20 minus 19 equals to 1. So the difference of neutron and proton are same, we can see. So these are isodiaphers. Next we are coming to isoelectronic species. Isoelectronic species. Now what is this species? What is this species? Atoms, ions or molecules. Okay. So species having same number of electrons. So it is being said that species having same number of electrons. For an example, if we take that C4 minus, that is carbon. Okay, carbon. C4 minus, then N3 minus, O2 minus, F minus, Ne, Na plus, Mg2 plus, Al3 plus, and electrons is 10. Okay, now you might be thinking that how the electron is becoming 10. Okay, atomic number for sodium is 11, but how is coming 10? It is because you can see in the subscript it is written as plus in case of sodium Na, that is it is an ion, so it has already removed its electron, that is In its shell it was 2,8,1 electronic configuration. Now it is 1 is being removed, 1 electron is being removed, so 2,8, that is 10. Okay, in this all are same, so electrons is 10 in all these elements, sorry, ions. Next is isostars. What is this isostars? Species having same number of atoms, so same number of atoms as well as same number of electrons. For an example, if we take CO2 and N2O. Now number of atoms, okay, number of atoms, it is also called atomicity. Carbon it is 1 and oxygen it is 2. So 1 plus 2 equals to 3. Next in N2O, 2 plus 1, that is 3. Now number of electron, carbon is 6, atomic number 6, and oxygen atomic number 8. So 8 into 2, that is 16. So 16 plus 6 gives you 22. In case of N2O, nitrogen atomic number 7, 7 into 2 is 14, and oxygen is 8, so 22. Now these two sentences are very important. All isoelectronic species are not isostars. Now you have to think about the conditions. In case of isoelectronic species, what it was, that same number of electrons, and in case of isostars, it should be same number of atoms as well as same number of electrons. But in isoelectronic species, it is the condition is not that it should be same number of atoms. So this sentence is wrong. All isoelectronic species are not isostars. Next is all isostars are isoelectronic species. Now conditions for isostars is what? Number of atoms should be same and number of electrons should be same. In case of isoelectronic species, only number of electrons must be same. But this is true. This is true. Isostars having same number of electrons, and isoelectronic species is also having same number of electrons. So this sentence is true. Next is nuclear isomers. What is this nuclear isomers? Species of same element having same atomic number. So same atomic number, same mass number, but different nuclear properties or different half-lives. So what are the conditions for different half-lives? So what are the conditions for nuclear isomers? First is atomic number should be same, mass numbers, second is mass number should be same, and third is should have different nuclear properties or different half-lives. So what is half-life? It is the time taken for species to become half of its initial concentration. Next we are coming to mole. We do not have to look into the example of nuclear isomers. Next we are coming to mole. What is mole? It is the SI unit for amount of substance. In physics, in the chapter of units and dimensions, you will read that 7 fundamental units. In that mole is there, which is the SI unit, systemi internationally, for mole of substance. So it is the SI unit for amount of substance. Now what one mole contains as many entities or particles, atoms or molecules as there are in 12 gram of C12 atom. Now what is this C12? Carbon has two isotopes, C12 and C14. So that is one is C12 atom. Okay, now 1 mole equals to, this is very important, you must note it, 1 mole equals to Avogadro's number of particles. 1 mole equals to Avogadro's number of particles. And what is this Avogadro number of particles? It is denoted by Na. It was established or discovered by a scientist known as Emilio Avogadro, which is equal to 6.022 into 10 to the power 23 particles or mole. Now what is now 1 mole of oxygen gas? 1 mole of oxygen gas, that is Na number of O2 molecules, that is 6.022 into 10 to the power 23 into O2 molecules. Next is, that is 2Na, number of O atoms, O2, right, O2. So O2 is a molecule, so it has two atoms which combine together to form a molecule. So 2Na, 2 times of Avogadro number. Okay, now next there is a question, number of charge in 1 gram ion of Al3 plus, aluminium 3 plus, in terms of Na. Now this is the answer, that is 3Na. Now how? So 1 Na, okay, so number of charge in 1 gram ion of Al3 plus. First we will see what is this gram ion. Okay, now if in the question it comes gram molecules, gram atom or gram ion, you will simply think it as a mole. That is, the question becomes number of charge in 1 mole of Al3 plus in terms of Na. Okay, so you can see that what is the charge of aluminium? 3 plus. That is, it is containing 3 charges. So we will simply write, what we will write in terms of Na? 3Na. Okay, next we are coming to relative atomic mass. Okay, what is this relative atomic mass? Relative atomic mass equals to mass of one atom by 1 by 12 into mass of one C12 atom. So this should be noted down. Okay, this we have to learn. Now relative atomic mass is a simple ratio, so it will have no unit, and it is represented as R dot A dot M, RAM, in capital letters. Next we are coming to atomic mass. Now atomic mass, what is this? The definition is mass of one atom is called atomic mass. Unit is A dot M dot U or simply U. Okay, this should be noted, denoted by AMU or U. Now this is very important. 1 AMU equals to 1 by Na gram, that is equals to 1.67 into 10 to the power minus 24 gram. This should be noted. Next we are coming to gram atomic mass. Now what is this gram atomic mass? Mass of 1 mole of atoms, GAM, represented by GAM. 1 mole of atoms means molar mass. Now RAM of carbon is 12, so AM, 12 AMU, that is atomic mass. Now molecular mass is 12. This is very important, you should understand this. Okay, that is, relative atomic mass is having 12, it is a simple ratio, so no unit. Now atomic mass, it is having 12 AM, so unit. And molecular mass, so what is the molecular mass? It will be simply 12. Okay, now these are the list of molar mass, you should learn by heart. Okay, it is very important, all these numbers you have to learn by heart. Okay, now we will talk about some specific elements which are having isotopes. Okay, now boron is having two isotopes, B10 and B11. Chlorine is having two isotopes, as I said. Okay, chlorine is having two isotopes, 35 and 17. Okay, next there are no isotopes here. These are also very important. Okay, this also should be learned by heart. Next is these salts formulas, this also should be learned by heart. Okay, next this diagrammatic representation. This diagrammatic representation is very important. Now if in a question it has been given mass, so if we are required to say that we have to find the number of moles of molecules, so simply we will divide the given mass by molecular mass, okay. And if the reverse happens, so we will simply multiply with the multiply the such as we are required to find the given mass, so we will multiply molecular mass into number of moles of molecules. Next, if we are required to if in the question it is being given number of moles of molecules and we are required to find number of molecules, so how we will find? By multiplying Avogadro number. And if the reverse happens, that is number of molecules is given, if the number of molecules is given and we are required to find the number of moles of molecules, we will simply divide by not simply, sorry, we will divide by number of molecules divided by Avogadro number, so we will get number of moles of molecules. Next, if we are given to find the total number of atoms, so what we will do? The number of molecules into atomicity. Atomicity, as I have said, that number of atoms in a molecule of the compound, okay. So total number of atoms, how we will find? The number of molecules into atomicity. Now when the reverse is required to find, so what we will do? Total number of atoms divided by atomicity, we will get the number of molecules. Next, if we are required to find the total number of charge, so what we will do? The total number of molecules into number of charge in one molecule. If we do this, we will get total number of charge. And this charge, if we require to find in Faraday, charge of 1 mole of electrons, 1 Faraday equals to charge of 1 mole of electrons, which is equal to 96500 coulomb. So total number of charge divided by Na, and we will get the charge in Faraday. Charge in Faraday. Next, total number of charge to total charge in coulomb. So total charge in coulomb equals to what we will do? Total number of charge into 1.6 into 10 to the power minus 19. Okay. Then we will get total charge in coulomb. Okay. Next, if we are required to find now, if in the question it is given number of molecules and we are finding total number of electrons, then what we will do? The number of electron in one molecule we will calculate that, and we will do plus plus plus, and then we will get total number of electrons. The boxes which are given, you can see the boxes, okay. You can see these are the boxes and the formulas are being given, okay. Formulas are being given, and under that you can see that one examples are also given, okay, to find. So you will see, okay, this is not okay. This thing though I have told now only, sorry. 1 Faraday is equal to charge of 1 mole of electrons, and 1 Faraday equals to 96500 coulomb, okay. Now this is a question which you can find out with the help of this chart, okay. I am not able to circle the chart, okay. This chart, with the help of this chart you can find, okay. So this is let you try, okay. You please try with this question and put your answers in comment section. The answer will be shown in the next video, okay. Thank you everyone. Please subscribe my channel, like, share and comment. If you have any doubts, type your doubts in comment section. I will solve your doubts. Okay, bye.